Welcome to the IIT JEE crash course. Over the next several videos, you will find that your conceptual understanding is improving and your problem solving skills are also improving. But if you want that to happen, you need to follow along and solve the problems with me, which means keep a notebook and pen with you. Every time you see a problem, pause the video, solve the problem, and then watch my solution. These are revision videos. These are meant for students who have already completed 12th or are about to complete 12th. So let's get started. Problem number 1. So in this problem, a particle is moving along the curve. If it is moving along any path, remember that the velocity is tangential to the path. So when it reaches the point x equal to 2 and y is equal to 4, its velocity points along the tangent at that point. Now the slope of the curve at that point is given by dy by dx. Now y is equal to x squared, so dy by dx is 2x, and at this point where x equal to 2, the slope is 4. And if you look at this velocity, you will see that the x and y components, vy, vx, are also related by vy by vx is equal to 4. That's because vy is equal to dy by dt and dx by dt is vx. So the ratio is dy by dx. So straight away we have one equation, vy is equal to 4 times vx. We also know that the speed of the particle is 2 meters per second. So vx squared plus vy squared is equal to 2 squared, which is 4. So that is vx squared plus 4 times vx the whole squared. So that is 16 vx squared is equal to 4. And that gives us vx is equal to square root of 4 by 17. So what is vy? The question was, what is the y component of the velocity? The answer is 4 times square root of 4 by 17 meters per second. Let's go to problem number 2. So here a particle moves anticlockwise with a steady tangential acceleration of 1 meter per second squared. Now you have to remember the following. The tangential acceleration is the rate of change of the speed of the particle. Now the rate of change of the velocity of the particle is the total acceleration. That has a radial component, which is the centripetal acceleration, and a tangential component, which is the rate of change of speed. It starts at t equal to 0 with 0 speed. So at t is equal to 2, its speed at t is equal to 2, the speed is 2 meters per second. So the particle is somewhere here and it has a speed of 2 meters per second. So at that instant, its centripetal acceleration points towards the center and has a value of v squared by r. This is the acceleration in the radial or in the centripetal direction, and that's equal to 4 divided by 2, that is equal to 2 meters per second square. Apart from that, it also has a tangential acceleration. Let me try to draw that in a different color so that you don't confuse it with the velocity. So there is a tangential acceleration in that direction. And what is the magnitude of the tangential acceleration? 1 meter per second squared. Which means the resultant acceleration is in some direction like that, and it has a magnitude of, the total acceleration's magnitude is going to be square root of the radial acceleration squared plus the tangential acceleration squared, because they are perpendicular to each other. That is square root of 2 squared, which is 4, plus 1 squared, which is 1. So that is equal to square root of 5 meters per second squared. So this is an example of non-uniform circular motion. Let's go to the next problem. So in this problem, a 1 meter long, 1 kilogram bob pendulum is pulled aside so that it's horizontal and released from rest. The question is, when the pendulum makes an angle of 30 degrees with the vertical, remember it's moving in this direction, and it's moving in the arc of a circle, this is an example of non-uniform circular motion because it's speeding up as it goes. The question is, at this instant, what is the centripetal acceleration? Which means we just have to find its speed, since we know the radius, and the centripetal acceleration is v squared by r. The height through which it is dropped is this, and you can see from the drawing that this is also 30 degrees, and if L is the length of the pendulum, the height is given by L cos 30 degrees, which is equal to 1 cos 30 degrees. So many meters. So the decrease in the potential energy is mgh, which is equal to 1 kilogram, g is 10, and h is root 3 by 2. The decrease in the potential energy is equal to the increase in the kinetic energy, equal to half m v squared. M of course is 1, cancels, half cancels with this half, and we get v squared is equal to 10 root 3. The centripetal acceleration is v squared by r, and the radius is 1 meter. So the acceleration in the radial direction, that is towards the pivot, is equal to 10 root 3 meters per second squared. This is equal to v squared by. That was the answer to the question, but supposing I had also asked what is the tangential acceleration at this instant. Now that's also fairly easy to calculate. We just draw the free body force diagram as always. There is mg acting downwards, and there is the tension T acting. These are the two forces acting on the bob of the pendulum. Now the tension T has no tangential component, whereas mg has a tangential component. Let's find out what that tangential component is. This is the tangential direction, which is perpendicular to the radial direction. This is 30 degrees, and so this is going to be 60 degrees. So mg, which is the force of gravity, has a tangential component of, I'll write it here, mg cos 60 degrees, and therefore the tangential acceleration divided by the mass is g cos 60 degrees. Cos 60 degrees is half, so this is 5 meters per second squared. I didn't ask for this, but you see, by drawing a free body diagram, you can easily calculate this. Right guys, see you in the next video.